Hello, everybody, and welcome to Lesson 5.2, which is on solving polynomial equations algebraically. This lesson is fairly straightforward, really. It's just a bunch of practice at different ways to algebraically solve equations. No real big, strange new concepts. It's more of a general review on the different techniques that you use in different situations. So let's take a look at some of those different situations. I'll read this out loud. Like quadratics, some polynomials of higher degrees can be factored. A polynomial that cannot be written as a product of two polynomials with integral coefficients is called a prime polynomial. Okay, so to say that in simpler terms, a prime polynomial can't be factored. Okay, the only factors it has is itself times 1. Okay, that's a prime polynomial. Like a prime real number, the only factors of a prime polynomial are 1 and itself. There you go, same thing. Similar to quadratic, some cubic polynomials can be factored by using polynomial identities. So we've seen an identity before, which was this one, the difference of squares. A squared minus b squared equals a plus b times a minus b. So identities, in one sense of how you could describe them, would be to say that identities let you move between one way of writing something and a different way. So we could move from a subtraction way of writing something, a difference between two squares, into a multiplication way of writing it as the product of two factors. And in certain cases, one way of writing it may be more useful than the other. So you may want to be able to go from one to the other or in the opposite direction. Okay. Polynomials can be factored by using a variety of methods, the most common of which are summarized in the table below. When factoring a polynomial, always look for a common factor first to simplify the expression. Then determine whether the resulting polynomial factors can be factored using one or more method. Okay, so saying factors twice there, they're saying that, for example, like this one, difference of two cubes. So we can use this, shoot, I'm losing my vocabulary word, identity here. Can use this identity to produce these two factors. The right factor could possibly be factored further. That's kind of what they're saying when they say whether the resulting polynomial factors, so here's a polynomial factor, can be factored using one or more methods. All right, so here's kind of our summary table that we're looking at. And it's broken down by how many terms you have. So if you have two terms, if you have a binomial, you may have the difference of squares, in which case you'll use the difference of squares identity. You may have the sum of two cubes. So maybe your two terms are not square terms, but they're cubic terms, in which case there is a separate identity that is used. You might have the difference of two cubes. So I'll show you a diagram later that will kind of help you make sense of this one. If you have three terms, you may have a perfect square trinomial. You may have a plus b squared or a minus b squared, in which case we have identities for those. Or you may just have a general trinomial that doesn't fit this. Okay, it's kind of easier to read from the bottom, I think, first. So if we thought of like 2x plus 5, 3x plus 4, whatever numbers you want to fill in. So your variable has a coefficient. You're adding some term onto it. That's kind of the maximum of complicated stuff. You can shove it to some factor. And the expanded version will look like this: acx squared plus ad plus bc times x plus bd. So you've got an x squared term, you've got an x term, and you've got constant term at the end. And the coefficients depend on the coefficients of the x's in the factored form. So the coefficient of x squared depends on a and c. A is that coefficient, c is that coefficient. The coefficient of your x term depends on all four of these, a, b, c, and d, in a certain order. Okay, grouping is when we have four or more terms. So that's when we say, okay, I've got four terms. If I look at it, do I see x's common everywhere? No. Y's common everywhere? No. A's, b's? No. They're all mixed up all over the place. But I can make a group. I can say this first group, ax and bx, they share an x that I can factor out. AY and BY share a Y, I can factor that out. And then from there, I now have gone from four terms down to two things being added in total, two products being added. And we can factor out common factors there and end up with a fully factored form. Okay. So that's basically it. Some of these things, like these identities, are things that you could definitely do them in reverse. So if you start with a plus b, a minus b, and you drew that as an area model, you'd be able to see that you get a squared minus b squared, or if you foiled it, whichever one you prefer. I prefer to do those area models myself. So if we start with these, we can see it go that way. However, it's a little bit harder to start here and just find a way to produce the correct factors. So sometimes we list these as identities, as kind of known relationships that we can go to in a table. Although there are ones that by now I would hope that you're feeling pretty comfortable with. For example, like the difference of two squares is a pretty common one we use. Other than that, let's just review today's goals. So we want to be able to solve polynomial equations by factoring. We want to solve polynomial equations by writing them in quadratic form and factoring. So we'll get into what quadratic form means. It's a pretty cool idea, really. It's basically the idea, if I can give you a little preview, that if you have some really, really high order polynomials, so like x to the 10th or something, or let's say x to the 25th, you can call that x to the 5th squared. And you can basically take things that we don't have identities for. We don't have, a big list of ways to manipulate them, and you can kind of like squish on these things until they look the way you want them to look. So if you had something that was to the 10th power, there's a way to write it to the 2nd power that lets you use some of these kind of like 2nd power identities that we've become familiar with. So it's an interesting concept. We'll get to it at the end of the lesson, though. Today's vocabulary are prime polynomials, so that idea of polynomials that can no longer be factored, and that quadratic form that I just mentioned. All right, well, let's tuck in and get started.